Your FastMCP server is throwing errors left and right, but instead of helpful diagnostics, you're getting cryptic stack traces and inconsistent error formats that confuse both your logs and your clients. We'll implement two critical middleware layers, one that transforms raw exceptions into clean, standardized MCP error responses with optional tracebacks, and another that automatically retries failed operations with exponential backoff for transient issues like network timeouts. You'll see exactly how to configure which exceptions trigger retries, set maximum attempts, and inject custom error handling logic, all while keeping your core business logic untouched. From FastMCP server middleware error handling import, ErrorHandlingMiddleware, RetryMiddleware, hash comprehensive error logging and transformation, MCP, add middleware ErrorHandlingMiddleware, include traceback equals true, transform errors equals true, error callback equals myErrorCallback, hash automatic retry with exponential backoff, MCP, add middleware RetryMiddleware, max retries equals 3, retry exceptions equals connection error timeout error. This demonstrates the middleware pipeline pattern for cross-cutting concerns in RPC systems. The code shows two specialized middleware components, error handling and retry logic, that wrap the core request processing flow without modifying the underlying business logic. What makes this distinctive is the declarative composition. You define behavior layers separately, then stack them in the order you need, creating a clean separation between infrastructure concerns and domain logic. The pattern works by intercepting requests and responses through a chain of responsibility. Each middleware can inspect, modify, or short-circuit the flow before delegating to the next layer via call next. This creates a unidirectional data pipeline where preprocessing happens on the way in and post-processing on the way out, with error handling and retries implemented as first-class citizens rather than afterthoughts. The key insight is that infrastructure concerns like logging, retries, or authentication become reusable components rather than scattered code throughout your handlers. This approach solves the problem of concern tangling in distributed systems, where error handling, retries, and monitoring would otherwise pollute every endpoint. You get consistent behavior across all operations without repetitive code, and the pipeline model makes it easy to add or remove layers as needs evolve. The trade-off is slight overhead from the middleware chain, but the maintainability benefits outweigh this cost in most production systems where cross-cutting concerns dominate complexity. Let's break it down line by line. From FastMCP server middleware error handling import. This imports FastMCP's error handling middleware components. These handle exceptions consistently across all requests, preventing crashes from propagating to clients. ErrorHandlingMiddleware. ErrorHandlingMiddleware intercepts and processes exceptions before they reach the client. It centralizes error logging, transformation, and recovery, preventing raw stack traces from leaking to users. This is the middleware pattern for cross-cutting error handling in FastMCP. RetryMiddleware. RetryMiddleware implements automatic retry logic with exponential backoff for transient failures. It intercepts specified exceptions like connection error or timeout error, then retries the operation up to the configured limit. This pattern defeats flaky network issues without manual retry code. This closing parenthesis terminates the middleware configuration block, finalizing the setup for both error handling and retry logic. It ensures the middleware stack is properly constructed before the server starts processing requests. Without this, the configuration would remain incomplete, preventing the middleware from being registered. Hash comprehensive error logging and transformation. MCP, add middleware ErrorHandlingMiddleware. This injects the error handling middleware into the request pipeline. It centralizes error logging and transformation, preventing scattered error handling code across your application. Middleware pattern ensures consistent error processing for every request. Include traceback equals true. This enables full stack trace capture in error responses, critical for debugging production issues, as it preserves the complete error context, including file paths and line numbers where failures occurred. Without this, you'd only see the error message, making root cause analysis significantly harder. Transform errors equals true. Enables error transformation before they reach the client. Converts raw exceptions into standardized error responses, hiding internal implementation details while preserving essential error information. Critical for API security and consistent error handling. Error callback equals myErrorCallback. This hooks in a custom error handler. When errors occur, myErrorCallback receives the exception details for logging, monitoring, or custom recovery logic, critical for production systems where you need visibility into failures. Closing parenthesis for both middleware configurations. This finalizes the add middleware calls, locking in the error handling and retry behaviors for all subsequent requests through this MCP instance. Hash automatic retry with exponential backoff. MCP, add middleware, RetryMiddleware. This injects RetryMiddleware into the request pipeline, implementing automatic retry logic with exponential backoff. Critical for handling transient failures like network timeouts or temporary service unavailability, it prevents cascading failures in distributed systems. The middleware pattern keeps retry logic reusable across all endpoints. Max retries equals 3. Sets the maximum retry attempts to 3. This prevents infinite retry loops while giving transient failures, like network blips, a chance to self-correct. The exponential backoff between attempts, implied by RetryMiddleware, makes this more effective than simple retries. Retry exceptions equals connection error, timeout error. This specifies which exceptions trigger automatic retries. By targeting connection error and timeout error, it focuses retries on transient network issues while letting other errors fail fast. This is the standard pattern for resilient network operations. This closes both middleware configurations. The double parenthesis terminates the nested ErrorHandlingMiddleware and RetryMiddleware calls, finalizing their addition to the MCP server's middleware stack. Resilient error handling pattern. FastMCP's error handling middleware transforms unpredictable failures into consistent, observable outcomes, while retry logic converts transient errors into eventual success. The middleware chain order matters. Place error handling before retry logic to ensure proper error classification before retries attempt. This pattern turns chaos into metrics, making failures as valuable as successes for system improvement.
The error that speaks loudest is the one that never occurs.